collaborator / competitor. And also it decreased the risks of an innovation to fail, decreasing the costs by economies of scale, scope, saves on contracting costs, and speeds up innovation. So in this sense, a collaboration is fundamental for firms, for instance, to do radical innovations because they demand a huge amount of resources and it's a high risky investment. So collaborations reduce the possibilities, the risks involved into radical innovations. But on the other hand, there are problems related to collaboration. So it is, first of all, it's allowed only for research because of antitrust policies. And then firms cannot collude in the market itself, only the first stage before entering the market. And well, this is a problem for firms because they will share their knowledge, share their assets, to open up their capabilities to another firm that will compete in the product market afterwards. So in this sense, we bring all the empirical literature discussing this two-step process. There are some empirical evidence on collaborative R&D. I also added some evidence on the public role because this is something that we are going to discuss as part of this paper. Because firms they receive government funding for collaborative R&D. They do more R&D, as we see in this papers. Government funding for collaborative R&D is associated with higher productivity. Collaboration actually increased the publication of scientists when involved in academia, and there is public support that increases when there is public support, it increases the collaborative R&D. And also it changed the behavior of the universities and the scholars becoming more entrepreneurial. So those are some evidences on collaborative R&D. And as I mentioned, there are some pros and some cons that firms need to face when they are willing to engage into an R&D collaboration. So the pros is that, well, there's this knowledge exchange and there are higher innovation opportunities. So the firms are allowed then to pool financial resources, which increases the likelihood of innovations to occur. And they share risks and decrease the R&D costs. The cons, and this is an important element, is that the firms will share their knowledge with a competitor that can imitate the firm. So, for instance, sorry, if we have a firm that is very big and growing very fast, and if it decides to collaborate with one firm that is smaller in the ranking, this smaller can learn from the top firm and catch up in their technological capabilities and becoming a future competitor in the market. So this is a risk of engaging in a collaboration. Then a firm needs to be very careful about who to collaborate with. And also, there has been arguments that collaborations leads to market concentration. So in terms of the research gaps of this literature, we have been trying to do a literature review, and we observed that the literature is scarce on models that observes the macroeconomic impacts of those R&D collaborations. And also, in terms of the network structure, which is something that we would like to develop in this research, to observe how different actors interact. Because, I mean, the K+S, there is this competitive mechanism, but we would like to expand this by adding the cooperation as another element that can generate changes in the market structure. So firms focus on sharing tasks in the execution of research and innovation between different types of actors, which can be public or can be private, given their difference in productivity. And then we observe the relationship between private R&D collaborations and between public and private R&D collaborations, and how this improves the innovation outcomes and share risks and costs. So in the end, in a nutshell, our contribution is to model the R&D and R&D collaborations in this micro to macro ABM to observe the macroeconomic impacts of collaborations. So I've been repetitive, but this is important when I show you the model. So here, this is the Keynes Schumpeter model. Most of you are very familiarized with this model. So This is the Dosi et al. 2010, in which you have an economic system defined by a government that collects taxes and pay unemployment benefits, a consumption good firm that buy machines from the capital good firms and then produce final goods by using workers paying wages, and those workers buy the final goods produced by consumption good firms, and capital good firms that produce the machines and the innovation, improving the quality of those machines. And this quality is observed by two parameters of productivity, A and B. So here we have the description of the original K+S model, and in which the capital good firms, they compete. Our contribution is to look at the private R&D collaborations, or how these firms collaborate in the research process, and how this affects the whole macroeconomic structure. And also, this is the second step of our research, is to observe the role of public R&D. In the sense, we draw from the literature of the entrepreneurial state and the recent contributions from Francesco Lamperti, Maria Mazzucato, Andrea Roventini on modeling the entrepreneurial state in the Keynes meets Schumpeter framework. So here, this is how the innovation and imitation happens in the Keynes meets Schumpeter, the baseline original model. So innovation is seen as a two-step process. First of all, to observe if an innovation will occur or not. So each firm will use part of its past sales in innovative activities. And from these innovative activities, you have a Bernoulli distribution draw. And this, if positive, if the Bernoulli is equal to 1, then a firm will do an innovation. If 0, then it doesn't do an innovation. If it's equal to 1, then the firm does an innovation, and the innovation is successful, then the firm will draw new productivities for the new machine from a beta distribution, given some technological opportunities. So then you take this you draw these new productivities and compare them with the previous productivities. If the new productivities are better, then the firm starts producing the new machines instead of the former one, creating this new vintage of machines. And then imitation occur in a similar process. So every time step, you have one innovation draw and one imitation draw, and the imitation follows a similar procedure. You have a Bernoulli draw based on the amount of investments the firms do in imitative activities, which is part of their total R&D expenditures. And if the Bernoulli draw is successful, the firm will imitate one random competitor. So it's one random competitor, but this randomness is weighted by the technological distance. So a firm is more likely to imitate those that are near them in terms of the two parameters of technology, A and B, given by the Euclidean distance between those parameters. So then this is how the innovation and imitation occur in the model. And then we are going to expand it, adding the R&D collaboration. So then in order to do so, we create a new module in which first we look at collaboration and the decision to collaborate or not. And if the firm decides to collaborate, it needs to find a matching into another firm. So this is the first step. The second step is to add collaboration as an element of innovation. The third, to add the collaboration for imitation. And finally, every time step, in the end of step, we check if the collaboration can continue in the next period or if it breaks. And this is based on some specific rules of behavior. So here I show you a chart flow chart explaining a bit how it works. Then a firm will decide to collaborate or not. If the draw is positive and it collaborates, then it checks potential collaborators. There is a matching process. Then if found one collaborator, what type of collaboration is going to happen? Then they implement the project and compare it with how it would have behaved if they worked by themselves alone. Is it better? If it's better than working alone, then they start the collaborative innovation process. And then it will draw new innovations. If the innovation is successful, draw new technologies. If the new technologies are better than the previous one, firms start producing it, and then you restart the process. So this is an expansion of the K+S by adding a new module of behavior. So first of all, the decision to collaborate, which is the first decision that the firms does. How does it feel? Does it need to collaborate or not? So the idea to decide if a firm wants to collaborate or not is based on this observance in the literature that firms want to protect their market position. So firms want to protect their market share. So if they feel that their position is threatened, then they start being more aware of the current situation and they be aware of being kicked out of the market. So they are more willing to engage into a collaboration. So if it threatens the maintenance of firm's market position. But then on the other hand, you have the trade-off because you have the risk of allowing other firm to access its technology. So it's not only to collaborate or not, but who to collaborate with, and then you kind of make a calculation if it's worthy or not. So in order to decide who to collaborate with, the matching process, we create a collaboration matrix, the collaboration probability matrix, and then use technological distance to measure the likelihood of one firm to collaborate with another. So in this initial stage of the research, we only accept one collaboration per firm. So we limit the number of collaboration, this parameter L equals to 1, but we could generalize that to more than one firms, which would create interesting patterns of networks. So the collaboration decision, the first step of the collaboration process, is a Bernoulli draw if a firm is interested or not to collaborate, and given probabilities based on the growth of market share. So the idea is very simple. If the market share M is decreasing, it's more likely that the firm will engage into a collaboration because it's more afraid of losing its market position. So then we have a parameter that is given by institutional conditions of the market, and this T, which is this phi, and this theta C is the Bernoulli coefficient. That's exactly like that. And then we draw from the Bernoulli, well, there's a B missing, sorry for that, which would give us if the I is equal to 1 or 0. If it's equal to 1, then the firm will engage into the collaboration process. If not, they prefer to work alone. So if the firm decides to engage into a collaboration process, it needs to find a matching. And this matching is given by the collaboration probability matrix. So the larger the distance, the smaller is the likelihood to collaborate. So firms want to collaborate with those that are closer to her. For instance, if a firm that is it's a top performer, starts collaborating with a bottom performer, well, this is only good this is much better for the bottom performer in principle, because it can copy the top performer and the vice versa wouldn't be relevant for the top performer. So those who are nearby are less riskier to be copied. So that's the idea behind that. And then you have a parameter that measures the strength of the probability. So if it's more likely to collaborate with your neighbor or not. And then you have the two probabilities, A, which is the probability of the machines, and B, if the probability, the probability of the machines to produce final goods and the probability to produce the machines. And tau is the vintage. We can also add size. I haven't done that, but we could use the Euler model somehow to put the distance and the size as the two magnitudes, and I'd like to do that to see how the model will behave. After the choice of collaboration, then the matching process, as I mentioned, will depend on the probability collaboration matrix, this P matrix. And then, as we only have one possible collaboration per that a firm can have with another firm, each firm will collaborate, will draw one another that is a potential collaborator. And this another firm, there's another firm J, is given by the probability matrix. So it's more likely to this firm J be drawn by a neighbor. So then we have to ask, if J is drawn, we have to ask J if J wants to collaborate with I. So then we have another line of code to ask that. If they do both engage into a collaboration, and they then the matrix of collaboration will receive the number 1 for the relationship between I and J. And they can only collaborate among themselves at this point. If they want to engage another collaboration, they need to break this collaboration. So then we create a network, from the collaboration matrix, which is an adjacency matrix of a network when we're doing a network analysis. And we can derive an edge collaboration list as well. But this case, it's not that interesting because this is a non-contiguous network, as we have only one possibility. But then I will discuss in the next steps what kinds of other types of possibilities we could do. Second step after the collaboration is to observe how innovation changes when firms collaborate. So first of all, which is the most important element that we have added, is the R&D pooling. So when firms collaborate, they draw the resources together to apply into our innovative activities. So they merge their R&D expenses, which is a fixed share of past sales, as it is in the original K+S model. So the R&D, when there is collaboration, will be the sum of the past sales for firm I and firm J. Given this part of, which is a part of total sales that go to R&D activities. So the firms that do not collaborate, they use only their own sales, as in the baseline model. And as this is only a module, this is something I'm adapting to the K+S. The past sales in this module are linked to past market share, so then we have a path dependency in terms of sales. Then, as it is in the K+S, we have the two-step process of the innovation process. First, the Bernoulli draw that attempts to innovate or not. And this Bernoulli draw is given by the R&D expenses based on past sales as part of the total sales. And in which C is the amount of R&D invested in innovative activities. In one minus C is the part invested in imitation, but this is what it is in the K+S as well. So if this Bernoulli draw is successful, then we move to new probabilities. And these probabilities are drawn from technological opportunities. So we have a beta distribution with alpha and beta as defining the shape of the distribution, and the X bar and the X underscore as the support of those technological distribution. Then this delta is what I call technological opportunities. We consider them fixed at this point. So what happens is that, you have, fixed in terms of the parameters, but then the beta distribution is a random variable. So we take one new element from the beta that will define how strong the innovation is. And then this is very similar to the K+S model. We don't change anything here. Well, the only big difference is the pooling resources at this point. Then we have an imitation with collaboration, which is kind of analogous. So the process is similar to the K+S. First, a probability to imitate a firm depends on the technological distance. So firms are more likely to imitate those that are neighbors. But when firms collaborate, they are in the same place. So you reduce the technological distance to 0. So for this specific calculation. It's not that they have a technological distance equal to 0, but just for this specific calculation. And then the likelihood, if the firms do imitate another, the amount of imitation will depend on the absorptive capacity, which is given by accumulative knowledge. But I'll be back to that in a bit, because the thing is, we have to calculate a probability to imitate coming from this matrix, which is given by the distance. But as the distance is equal to 0, what's happening is that we can end up dividing by 0. So then we get an error. So in order to solve this, I added a cap to the maximum probability of a firm imitate its collaborator. So the maximum probability is given by this aleph letter that gives, like, if aleph is equal to 0.8, then if an imitation is successful, there is 80% of chances of a firm to imitate from its collaborator. So then I define exactly what kind of probability I would like to have. Then after the imitation is successful in the Bernoulli draw, that we do it a similar way as we did before, then there's this new draw, then the firm will imitate another. And this another is draw by this probability matrix. And then if the firm that is draw, it has a better technology than the one that draw it, then the firm who draw it, the firm I, copies the firm J. So sorry for the confusion. The idea is just that one firm can copy a random competitor. If the random competitor is draw, then it can imitates its technology given the absorptive capacity. That's the idea. And then at every time step, there is a probability to break the collaboration. The way I have just modeled it, it's very simple, but I'm offering some other possibilities. So a firm will break the collaboration if in the next step, market share is reduced. So the firm wants to engage into a collaboration. In order to protect this market share, if after the collaboration happens, the market share is reduced, the firm says that it's not worth it to continue collaboration and it breaks it. That's the idea behind it. Then I implemented those in R. So I have a module of the K plus S that I need to implement yet in the original model. So I have some basic results of this specific behavior. I run for 20 times with 800 time steps for 20 firms. So this is a very small experiment, only one collaboration available. And for the technological opportunities parameters, which are those in the middle, I use the same calibration as in the K plus S. And here are the variables for the likelihood to imitate, to innovate, and also to draw a competitor. So here is the collaboration distribution. This is the collaboration rate I have in the model, which is around 30% on average. So there's 30% of collaboration on average in my model. 30% of firms collaborate, sorry. And so then here, when I run for one simulation, I can see how the behavior of the firms would occur when there is and when collaboration compared to when there is no collaboration. And here we see two interesting things. First, well, a collaboration increases, the slope of the productivity increases, and it also reduces the number of times that a firm stays lagged. So it's much smaller in this sense. I have some statistics to show that, but I wanted to show the graph in order to give a glimpse on how it works. This is for productivity A, this is for productivity B. Then some basic statistics. When there is no collaboration, the productivity growth is 4% on average, 5.4%. When there is a collaboration, is 5.3. It also increased for productivity B from 5.6 to 6.8. And this is something I found interesting because I was expecting that collaborating firms would end up generating a more concentrated market structure, but it was opposite in my experiment. But this is something I need to further investigate, and also when I add this to the K plus S baseline model. Then the distribution of innovations is interesting because this shows that when there is collaboration, innovations the number of innovations increases. So there's more innovation when there are compared to there is no collaboration. So here we can see in red compared to blue. This is the same for imitation. So a collaboration increased the imitation rate, which is something that was also, I mean, it's expected, but it was interesting to see the data and how much this affects. And also, as I mentioned before, the Herfindahl-Hirschman distribution actually changed to the left of the distribution. So a collaboration decreases the market concentration, which is something I found interesting for the results, but as I mentioned, it needs to be better investigated. Then, just to show some next steps and some ideas that I have that we have been discussing and what we could do. First, and this is something we need to do anyways for the project, is to add public firm and expand technological opportunities. So in order to do so, my idea is to bring this paper by Dosi, Lamperti, Roventini, Mazzucato, and et al. When there's a collaboration with a national research lab. So in this case, the technological opportunities change. So before we had that those parameters alpha, beta, which are parameters of the beta distribution, and the support X bar and X underscore, they were fixed, but with the presence of a national research lab, we can make them endogenous. So then in order to do so, we have a two-step process again, running a Bernoulli to see if collaboration increases technological opportunities. If it does, then the technological opportunities increase based on this beta distribution draw. So it's a similar process as in the innovation, but then I need to decide if I change only the parameters of the beta or the support. But in any case, I need to do some possible simulations to see that, because this is a change to the whole structure of the model and not only to individual firms. So a change in technological opportunity needs to happen to everyone, not only to one specific firm. And this is something that needs to be better taken care of when I apply to the model. Then the second step, something that I've been doing exactly this week, is to endogenize the absorptive capacity. So I'll take this paper by Emanuele Russo and Andrea Roventini, and they propose two dimensions to endogenize absorptive capacity. So the ability to access technological distant coefficients and the speed at which the newly imitated techniques are exploited. So take the second dimension. So firms will be able to absorb more from the collaborator or just some other firms that they successfully imitate. So this is mainly the idea that it's higher, the imitation happens at a higher rate than before. And then we have this equation that depends on this parameter for the upper bound and the speed of adoption, given by the cumulative sales. So the cumulative knowledge affects the absorptive capacity of a firm. Then another thing that I'd like to do, and something that wouldn't be so complicated in principle, is to add other rules to break the collaboration. So not only the market share in the previous period, but also add a rule in which firms break a collaboration when they are not successful in a number of specific simulations. So if they collaborate and they're not successful in an innovation for 5 periods, for instance, then it's not worthy for them to continue collaboration because they have been putting a lot of resources and this has not given any payoff. Also, it's a possibility of increase the gap in market share. So it's not the previous market share that decides if a firm will collaborate or not, but also in some other time lags for going back to the past as well. And also after a radical innovation, if we include the public firm, the National Research Lab, because the idea of a change in technological opportunity is somehow linked to the idea of a radical innovation occurring in the system. So if a firm who collaborates, it can be with a public firm, a National Research Lab, or with another private firm, when there is a radical innovation, they decide not to continue collaborating. So this is something that needs to be added to the model as well. And also, well, this is an initial idea that to model what I just mentioned, so include innovations not being successful in the past, a market share in the past as well, and then how this would behave. And also, and this is something that I find it interesting for us to do, is to add an innovation policy. So because we allow firms to collaborate at the R&D stage, so we provide another competitive environment, stimulating R&D by changing IPRs, the patent regime, giving R&D tax incentives, subsidies, grants, so different types of policies that could affect the environment, and then see how it would result in the model, and collaboration with public research labs. So all these are ideas that, including the role of the state, the government, not only as absorbing taxes and paying unemployment benefits, but also with this active role in the innovation process. And then this is something that actually does something I find it interesting that I like to do if there's more time, and this is in part of the agenda, to increase the number of collaborations to more than one and generalize the model. So we can create contiguous networks like this one, in which we analyze characteristics of R&D networks, dynamic networks, how they evolve, the centrality, and all this analysis on networks that I find it interesting. It could somehow give us some information on how a collaboration occurs in general. So to conclude, the paper is focused on implementing R&D collaborations on the K+S. Those collaborations are based on empirical literature. So we had a strong literature review trying to raise the main concerns and use them to establish this model of R&D collaborations. We want the creation of this network that needs to be further developed, but I found that this could be the one way to move forward with our agenda. The role of private firms by pooling resources, and public and private by changing technological opportunities when engaging into collaboration. And we also see that collaboration, from our preliminary results, that collaboration increases innovation and imitation, but it does not increase market concentration. But this is a preliminary result. It needs to be much further analyzed and discussed. And this is a work in progress, as you realize when I was telling about the next steps. So all comments are very welcome, and then please feel free to address and with criticism, with suggestions. And I'd like to thank very much for the opportunity to present here. It was very nice, so thank you. Sorry, Andrea, I cannot hear you.
Yeah, sorry. Thanks, Danilo, for your presentation. And we can open the floor for questions. Are there are there questions? Or suggestions to Danilo, indeed, because the work is to some extent preliminary. Okay.
Yeah. Can you hear me?
Yes.
Yes.
Oh, okay. So phone is on. I see. Mic is on. Okay. This is Pedro Albuquerque, south of France, Kedge Business School. So thanks for the invitation, for watching. I'm not sharing my camera just because my bandwidth is not very good right now. So my question is, how? I mean, the results are very interesting. I mean, collaboration, the role of collaboration is something that I think really needs more theoretical investigation like you're doing. The thing is, what's the role of patents in all that? I mean, all kinds of property rights on ideas. Is there any way of putting that into the model in a more explicit way? So in terms of policies that could be evaluated, because obviously the interesting thing, I mean, the impression that I have that property rights on ideas are excessive at this moment and could hurt collaboration instead of improving collaboration. So do you have any comment on that? I mean, insight or maybe something that could be done in the model towards that policy question? So I'm going to cut my mic and thanks for the presentation.
Yes.
Danilo, I think you can reply. We take one question after the other.
Perfect. Thank you. Well, thank you, Pedro, for your question. Well, in the K plus S model, there is a module to involve patents. So this has been done. But in my specific module, I have not added that yet. So you're right. I mean, in the sense that maybe this would enter in this discussion that too much patent, but hurt the process, but too low also hurts it. So I don't know if you have any suggestions to work on that, how to add patents as one possibility, because, well, in the imitation process, we have only the absorptive capacity, but we are assuming that the firms, they freely open their knowledge to others. If there is patent, then this is not the case. So that could be another element to the trade-off for a firm to collaborate or not. Yeah, I'm sorry, I don't have a proper, like, very settled answer, but I'll be very happy to listen to any kind of suggestion on that.
Okay. Yeah, indeed, it's not going to be too much complicated to add the patent dimension as it is already there in the paper in the code. Thanks, Pedro, for the question. Other ones or other comments? Okay, well, okay. Thanks to everybody for joining this this talk, and we will meet again in 2 weeks with another talk. I guess it's going to be the last of the year. And thanks again to everybody to participate in this initiative of ABM4Policy, which I think is really helpful for our community.